Good day, children. Welcome to Part 4 of Solids, Liquids, and Gases. Previously, in this lesson, we were learning about matter. Matter is anything that has mass and takes up space. Matter is composed of molecules. There are three states of matter: solids, liquids, and gases. Each state of matter has different properties, and one state of matter can change to the other. Now, imagine what a fun would it be if you suddenly get some magical powers to change things around you. What are the things you would want to change? We do not have much magical powers, of course, but we can still change a few things around us and perhaps many things. Every day, we come across many changes in our surroundings. These changes may involve one or more substances. Some changes occur in a minute or some take a longer time. Few changes are not even noticeable. Changes is happening all around us all of the time. Chemists learn a lot about the nature of matter by studying the changes that matter can undergo. They have distinguished between two different types of changes that they study. They are physical changes and chemical changes. Before entering into changes, you all must know there are two types of properties, namely physical properties and chemical properties. A physical property is any property that is measurable whose value describes a state of a physical system. Physical properties are often referred to as observables. Examples of physical properties include color, shape, size, density, amount, volume, solubility, and many others. Chemical property or characteristic of a substance that is observed during a reaction in which the chemical composition or identity of the substance is changed. Example, flammability, rusting, burning, corrosion, reactivity. Physical change. Physical changes are those in which a substance is not transformed into another. This means that the substance or substances present at the beginning of the change are there at the end of the change. The ending materials are the same as the beginning materials. Their properties will also be the same. Physical changes involve moving molecules around, but not changing them. There is no change in chemical composition and no new substance is formed. Some examples of physical changes include change in shape, size, change of state, separation of a mixture, physical deformation, or making solutions. Some activities that cause physical changes are grinding, cutting, crushing, bending, breaking, heating or cooling, and squishing. How can we find out that a physical change has occurred? There will be a change in shape, form, size, change in phase, and always or mostly physical changes are reversible. Some examples of physical changes include cutting paper, melting of wax, cutting wood, breaking pencil, dissolving sugar in water, breaking cookies. For example, if we have a piece of paper and when we tear it, we don't change it into something other than a piece of paper by ripping it up. What was paper before we started tearing is still paper when we are done. And this is a very good example of physical change. Chemical changes. Chemical changes occur when a substance or substances undergo a change in its chemical properties. This means that one or more substances with a certain set of properties is turned into a different substance with different properties. New substance with a different chemical composition is formed. Chemical changes are frequently harder to reverse than chemical change. Examples of chemical changes include burning, rusting, digestion, decomposition, and growth. We actually can't see the molecules breaking or forming bonds, although that's what defines chemical changes. We have to make other observations to indicate that a chemical change has happened. So some of the evidences that a chemical change has occurred includes temperature changes, unexpected color change, bubbles are formed, changes in physical properties, different smell or taste. A solid forms if two clear liquids are mixed. And during a chemical change, energy is either released or absorbed in the form of heat, light, or sound. Example of chemical changes: baking, rotting of apple, leaves changing its color during autumn, souring milk, fuels burning when a rocket is launched, burning firecrackers. Consider the example of baking a cake. We use various ingredients to bake a cake, like wheat, eggs, sugar, and different kind of essences. Each of them have different molecules and different molecular arrangements. But once they are put together and baked, they undergo a chemical change, change in their chemical properties, and we get the final product as a cake. We are not able to get back the original products which were used, and hence it is a very good example of chemical change. Expansion and contraction. We have seen that changes in heat energy affect the movement of particles even if there is no change in state. An increase in heat energy makes the particles to move faster. A decrease in heat energy makes the particles to move slower. Expansion. When the movement of particles speeds up, there is an increase in the space between them. An increase in the space between particles means that the substance expands. There is no change in the number of particles and their size also remains the same, but they take up more room. In other words, there is an increase in the volume it occupies. Contraction. When the movement of particles slows down, there is a decrease in the space between them. A decrease in the space between particles means that the substance contracts. In other words, there is a decrease in the volume it occupies. This general relationship between particular movement and volume is the same for solids, liquids, and gases. However, the extent to which substances expand or contract varies between the different states of matter. Solids expand negligibly when heated, but liquids expand more than solids when heated. This is because the particles in liquids are not held in a fixed arrangement as they are in solids. So this increased freedom of movement results in greater expansion. Gases expand much more than solids and liquids when heated. This is because the particles in gases are not held closely together as they are in solids and liquids. but are instead free to move in all directions. Thank you.